Today we are at the National University of Science and Technology, where we're going to be talking to Mr. Zephaniah Dlamini, the director of the Applied Genetic Testing Center, who's going to explain to us issues around DNA concerning the case of the Cholocho 9-year-old. Welcome, Mr. Dlamini.
Thank you, Robin. Welcome to the Applied Genetic Testing Center here at Nust. As you know, this center deals with DNA testing for various applications in human identification, forensic science, as well as pathogen identification, identification of livestock and crops. We use DNA to identify individuals. Why? Because DNA, deoxyribonucleic acid, is the chemical of life. All life forms have genetic material in the form of DNA. Now, this DNA is inherited by individuals from their parents. Individuals like human beings, animals, usually have two pairs of chromosomes. So you get half a pair from your father and the other half from the mother. So if we are looking at a complement of DNA markers covering the genome, the whole genome of an individual, you realize that all these markers will occur in pairs. And you get half of those from your mother and the other half from your father. So with that, basically, there are no two individuals who have the same DNA combination of these markers, except identical twins. Identical twins will have exactly the same DNA. You realize that if you have a man and a woman having a family, all the children will have different combinations of these pairs of DNA markers. So no two children within a family will have exactly the same combination. Now, with this case, the Cholocho case, where we hear a 9-year-old child is pregnant and the suspect is the father to this child who has impregnated her. So as you are asking, is it possible to distinguish the DNA of this man in this child who is supposed to be his grandchild and now is supposed to be his father? Yes, it is possible, because yes, we appreciate that the 9-year-old girl, half her DNA came from the father. But you have to recognize that he gave her only half. The other half he didn't give to her. Okay. So there are some markers that are found within the father that will be found in the 9-year-old, who is now a mother, being fathered by, being impregnated, by her father. Yes. If that is true, then the child will have DNA markers which will be clear from the mother. We will analyze the DNA of the mother and then analyze the DNA of the suspected father. And then, yes, it will be possible to tell if he is indeed the perpetrator of the rape, or he can be excluded if we do not find his DNA in the child who is to be born. The importance of this is that we have to test the mother, the 9-year-old. We test her, we see what DNA marker combinations she has. And then we test the newly born and see what DNA markers she has. And then immediately, looking at the newborn child, we compare with the mother and eliminate all the DNA that we are seeing that the child got from the mother. Okay? When that is done, the remaining half has to match 100% with the suspect, who is the father. Yeah. So it's a simple case. It can easily be resolved. Yes.
And what are some of the challenges that come with this combination of a father and a child producing a child together?
Yeah, this is incest, where you have, a parent impregnating their own offspring. In applied genetics terms, we call it inbreeding. You see, for a healthy society, you need people not to mate within families, because that causes problems. Because if there are genetic defects, they may be recessive, lying dormant, we're not seeing them. But now if we let these people mate or reproduce amongst themselves, those defects tend to come up and show and manifest themselves a lot. I'm sure if you've read classical genetics cases of inbreeding, the British royal family is considered to be inbred. Okay. Because you find that Prince Philip was a cousin to Queen Elizabeth, but they had children. Okay. And also there was a defect that occurred in the royal family, and that defect is called hemophilia, okay. The inability of blood to clot. So you find that a lot of Queen Victoria's descendants, the male ones, had this defect. Okay. So it is running in the family. So if you have people who are closely related, getting married and having children together, you tend to see this defect coming up in a higher frequency than it would have been if people were marrying from distant families. So there are a lot of other genetic defects. The most common one is albinism. You can have two people who are seemingly normal, but they carry half the DNA for albinism, the allele for albinism, but it is being masked by the normal pigmentation DNA. But now if you get these people with the albinism DNA, if they're closely related, having children, the probability of you having people who are albinos or who have the phenotype of albinism increases. Okay, so the inbreeding is not encouraged at all, even in animals. Excuse me. Even in animals, you hear our farmers saying, "No, I have to remove this bull because it will start following his daughters." Okay. We don't want that because it brings in inbreeding, and if there are genetic defects, we start seeing them manifesting in the offspring. Yes. Okay. So at the DNA level, for instance, I can probably predict an inbred individual won't show much genetic diversity. That is the combination of different markers in their DNA. It won't be much. Let us say, for instance, the mother, in this case the 9-year-old, has a gene which we'll call, hypothetically we'll call it C57, okay? And then the father also has a C57, obviously, If the daughter gives the child to be born, the 9-year-old gives her child, that's C57, and the father, who is supposed to be the grandfather, also gives a C57. So instead of having two peaks, you get one long peak, meaning this person is homozygous. We call it homozygous because he has one form or one type of a DNA marker at a particular locus. In the analysis, it will be interesting to look at. You see a lot of homozygous combinations, meaning that showing us it is an inbred individual.
Okay. You spoke about albinism. Besides albinism, what other defects could this offspring have?
Oh, there are a lot of. Well, it depends on what genes for genetic defects exist in the family.
Okay.
Right. If in this father's family there are these defects which are recessive, meaning they are being overpowered by some DNA, which probably came from maybe the mother to the 9-year-old, came with stronger genes that are suppressing these defects in the offspring, in this case the 9-year-old. Now that there is no external DNA pool coming in to this family, you are circulating the genes amongst themselves. They may start to appear. I don't know. Maybe they may have blood clotting factor problems. They may have dwarfism. They may have some. There are a lot of genetic ailments that can manifest themselves as a result of inbreeding. Yes.
Okay. So, in the absence of DNA, how could such a case have been solved?
It would only be speculation. It will only be speculation. There will be there is no way you can tell other than looking at the DNA. Yes. Okay. Absolutely no way. Yes.
Well, thank you very much for your assistance.
Okay.
That was Mr. Zephaniah Dlamini explaining issues around DNA and how it can be used to solve the case of the 9-year-old in Cholocho. Thank you very much for watching.